today's video, we're talking about making valid measurements. All right, so now let's just kind of define valid measurements. Now, with this idea, there's always some uncertainty in measurement. This means that two people can look at the exact same tool and record slightly different measurements. But the important thing is that both are still valid. Now, that does not mean that all of our measurements are actually right. And this ties back to our idea of accuracy and precision. And so let's kind of go through and talk a little bit about the different types of measurements that we can take. And so the first one happens to be length. So for example, we can say that for sure the pencil, which remember is the second one, is about 16 centimeters long. Now, the important thing is that we cannot say that it's exactly 16 centimeters long. Now, why can't we say it's exactly 16 centimeters? I mean, if we look up, boom, looks like it's right to the edge of the pencil. But the important thing is that for valid measurements, all valid measurements must include at least one digit that estimates beyond what the lines on the ruler actually tell us for sure. So for example, that means if we're looking at a ruler here, yes, it only goes up by, ones, like it goes from 15 to 16 to 17, but that means we have to estimate one spot or one digit past what we actually know. So for example, some of the valid measurements for our pencil actually include saying it's 16.0 centimeters, or maybe you think it's a little bit short, and we'll call it 15.9 centimeters. Now, there are some kind of other ones. If you think it looks a little longer than that, maybe it's 16.1, and so on. Now, the idea here is that the difference is that we estimated that one digit. So notice we thought it was 16, but in reality, we have to estimate one spot after that. So let's kind of take a second and talk about that. So we're just going to use just lines up to a decimal, and then we'll include a couple lines afterwards. So if we're talking about a number here, so let's just use our number A, B, C, D, E, F. So A represents the hundreds place. B represents the tens. C represents the ones, and then after the decimal, it represents the tenths, hundredths for E, and thousandths for F. And so what that really means is that if we are confident, meaning our measurement tool shows us one of these, like let's just say if we're looking at our pencil, it's showing us the ones, we have to estimate the next place over. So that's the key here, is estimating that next place over. So in terms of some of our other measurements that are not valid for our pencil, would include something like 16 centimeters, because remember we need to estimate one extra spot, or just something way off like saying it's 16.5 centimeters. And so the key here, remember, is you have to estimate the next guess or the next possible spot. So now that we've talked about length, let's talk about our next one, which happens to be volume. So our question is, what is the volume in the graduated cylinder? Now, for sure, we can say that in our graduated cylinder, it's about 43 milliliters. Now, for this, we've used the bottom of the meniscus. Now, the bottom of the meniscus is the lowest possible point. So in our close-up view, we see that the lowest possible point is right about here. And so then we looked closely at the lines and the meniscus. And the meniscus here sits at about, or sits on about the third line above 40, which means that if we're looking at our graduated cylinder here, if each of these lines represents an increment, that means that each line must be worth about 1 milliliter. But the key here is that we cannot say that it's exactly 43 milliliters. And so that's the big thing. It must be just a little bit more or less. So some of our valid measurements could include, or a valid measurement rather, will include just like one digit that estimates beyond what the lines on the graduated cylinder tell us for sure. So just like we did with our length measurement, we have to do the same thing with our volume measurement. We have to estimate one digit. So some valid measurements for our volume would include something like 43.0 milliliters, or maybe even, if you think it's a little bit less, maybe 42.9 milliliters. As well as others, if you think it looks a little bit less than that, you could even call it 42.8. And so the key here is that the measurements for the volume have to include that one extra estimated digit. Now, some of the measurements for the volume that are not considered valid would be something like just 43 milliliters being a number that does not estimate a digit, or something else like way off, such as maybe even 46 milliliters, and obviously many more. And now let's kind of talk about possibly the easiest one, which happens to be mass. And so our question here is, what is the mass of the plastic dish? Now, when it comes to mass, because we're using digital scales, there's a lot less thinking involved with measuring mass. So if we're talking about what the mass of our measurement dish is, or what our plastic dish is, if it looks like this, there's only really one valid measurement. And that happens to be what the scale actually tells you. So this mass happens to be 2.87 grams. Because remember, in our picture here, that's what it's showing us. But in reality, what this is saying is that it doesn't mean the mass is exactly 2.87 grams. So that just like we were doing before, the scale is actually doing the same thing. It's telling us that the final digit is an estimate. And so if we, kind of had a more precise measuring device, the mass may actually be, in reality, 2.86874349 grams. But the balance just isn't sensitive enough to actually show this. And so the important thing here is that if the last digit sometimes says 6, sometimes 7, sometimes 8, which does happen if you guys have used scales before in other science classes, sometimes the scale kind of bounces around a little bit. This happens just because this is some kind of estimate. Now, the other reason that this really happens too is because it's an estimate, the tiniest changes in like airflow actually have an effect on the scale. So something as simple as like the air conditioner blowing on the scale could actually cause this effect to happen, where your scale doesn't really balance out and it just kind of bounces back and forth between different numbers. And so now that we've kind of talked about mass, let's kind of talk about the next one. And this idea is when it involves zeros. And so let's just kind of take a look here. And so if we're looking at our scale here, we have a solid on there and it says 50.00. So what would you write down for this mass? Now, what you should write down is exactly what the scale tells you, 50.00 grams. Now, based on kind of what we've talked about so far, the digits that we know for sure are the ones that aren't estimated. Now, remember, even scales estimate the last digit, which means that if we're putting a circle around the ones that we know for sure, that would be our 50.0, and that would include the first zero. Then the digit that's an estimate, and we're told we need to draw a triangle around that, that would be the very last digit. So the last zero is an estimated digit. Rule on a balance, if the last digit is a zero, you have to include it. And so the reason that you do is it tells us that the digit is, or the digit before it, rather, is one that we know for sure. And so this is crucial because if you think about something like how many cents maybe in a coin jar that you have at home, you can just give me a rough estimate. And so this is a very important part. Now, even when it comes to like science stuff, a lot of times we use a lot of rough estimates. And so it's important to know exactly what degree of accuracy we actually know. And so that's the key, is that understanding that difference between accuracy and everything else. So let's just kind of do a quick summary. So when it comes to our rules of measurements, first, if the tool has lines, remember this includes like rulers or graduated cylinders, your first step should be to figure out how much each line is actually worth. So sometimes it's worth 1, sometimes it's worth 0.1, sometimes it's even worth other things like 0.2 or 5. Now, after you know that, or what each line is worth, you determine what you know for sure, meaning you look at where that object kind of ends, whether it's an object that you're measuring with like a ruler, or if it's something like water in a graduated cylinder, you figure out exactly what you know, meaning you're 100% confident in that answer. And then finally, you estimate or add on the digit to the end that goes beyond or one place beyond what the line tells you. Now, if it's something else, like if it's a digital equipment, so whether it's a scale or maybe even a digital caliper, which is something that measures distance, you record exactly what the display shows, even if the final digit or digits are 0. And so that's really important that you include zeros no matter where they appear. And if the last digit doesn't stay the same, that's when you can estimate it. All right, that's it for this video.